Hey everyone, welcome back to the DP-700 exam preparation series. Today we're going to be getting hands-on in T-SQL. We're going to be looking at a variety of different things around data transformation, looking at dimensional modeling with T-SQL, all of the things that I think is really important for you to understand if you're taking the DP-700 exam. So let's get started. So I'm here in this notebook and I've got it attached, a T-SQL notebook this is, and I've got it attached to an empty data warehouse in Fabric. Now, it's impossible to say exactly what you need to learn for the DP-700 in terms of T-SQL knowledge, but it is assumed that you have a pretty good fundamental knowledge of a lot of the basics around T-SQL. So here I'm talking about things like where statements, select statements, group by, having inserts, updates, deletes, a ranking, union all, data types, creating views, stored procedures, functions, all of this kind of like basic syntax for T-SQL I'm not going to be dealing with in this video. So if some of these concepts are new to you, the ones that I've listed up in this top section here, then I recommend you brush up on those before we go into this. So the purpose of this video is to prepare you for the DP-700 exam. So I've chosen a few other topics that I think are important for you to learn about over and above those fundamentals. Now that doesn't mean that just because I'm not going to talk about them in this video here, the fundamentals are obviously very, very important. So you need to know these, but it would take hours and hours and hours to bring someone up from zero knowledge to, the level that is required for the DP-700. So I'm just going to be focusing on these elements here. So we're going to be looking at some methods for ingestion and table creation using T-SQL in a Fabric data warehouse. We're going to be looking at primary key constraints and the generation of surrogate keys and what that means in a data warehouse. We're also going to be looking at dimensional modeling in T-SQL. So how we can perform things like joins, SCDs, slowly changing dimensions, how we can construct our dimensions and our fact tables depending on what your modeling strategy is. We'll also be revising some of the concepts around security. So we're going to be looking at row-level security definition in a data warehouse. We're in T-SQL. Also object-level security and column-level security. Yes, we dealt with these in a previous lesson, but it's always good to revise and go over these things again, just so that you understand how that works in T-SQL. We'll also be looking at dynamic data masking towards the end as well. And we'll be talking about optimization, although optimization will be dealt with in a future video. So let's dive into this notebook, starting with section 1. So we have a wide variety of options available to us in the T-SQL language. This is not specific to Fabric, but I'm just telling you some of the different options available to you when you are wanting to create tables or ingest data into tables, right? So you might know some or all of these. So create table, statement is the most basic. We've got copy into. So if you want to ingest data from ADLS Gen 2, you can do that if it's CSV or Parquet. We also have these select into from and insert into from that allows us to essentially ingest data from one table into another table. There's also CTAS, so create table as select, right? So in that method, you're doing the table creation and the ingestion in the same process. So these are a wide variety of tools that is important to learn about just to understand the different options available to you, just to give you more strings in your bow, so to say. Just so that you understand some syntax, if you see this kind of thing written or you want to write this stuff yourself, it just gives you a lot of functionality and flexibility for creating and loading tables in a data warehouse. So let's walk through some of those. So the first one is around the create table statement. And obviously in Fabric, we cannot specify the primary key constraint during table creation. So if we were to run this cell here, which I've just run now, you'll see that we can't specify identity columns because identity columns aren't supported in the current version of Delta or the open source version of Delta. And we can't create primary key constraints on this table during table creation. So we'll look at how we can do that with the alter table statement shortly. The next one is this copy into statement here, right? We can use it to ingest data from ADLS Gen 2, and currently that's the only source, but I'm sure I hope they will expand that. It would be really good to use copy into from a Lakehouse files area. And they've also added support for trusted workspace access. So your ADLS Gen 2 storage account can be somewhat protected and you can bring those files in as well. Now, one other thing that I would mention is this one here. So it's also one of the fastest methods for getting data into Fabric. Okay, so if you've got Parquet files or CSV files in ADLS Gen 2, this is going to be they're really big files. It's one of the most efficient that I've found. The syntax, well, copy into a table here, dbo.contacts I'm using here. You'll have to obviously create that table before you can copy something into it. And all I'm doing here is I'm passing in the blob.core.windows.net address of the CSV file that I want to load in with some properties here. So I'm passing in the file type, and the first row is on row 2. So I'm just suggesting that here. There's lots of other properties that you can pass into this copy into. So if we look at the documentation and we scroll down to the syntax here, you can see some of the different properties that we can pass into that. One of the ones that they've recently added on the Fabric side is this date format. So if you have date columns, you can now format those correctly as well. So that's useful. So now we should have loaded some data into that table. Just have a look at them, dbo.contacts. So all I've got here is some customer data from HubSpot, some contacts data, which has a customer ID, customer name, customer city ID, and a customer email. Let's continue. So we've also got these other methods for table creation and what I would call table population, right? Ingestion into tables. So what we can do is we can create another schema here called silver and create a silver table. This time I'm using insert into silver.contacts inserts. And then after that, we've got this select statement. Obviously, if you're building this into some sort of ETL process, I'd recommend not using select star, but just using that for simplicity of this demo. All right, so I've just refreshed my data warehouse here that's attached to this notebook. And now you can see the silver and some tables. And so we've just created in this step here, our silver table, silver contact inserts. And then what we've done is we've just shown that we can insert data into that table from another table. Essentially quite basic still. We can also do select into a table from dbo.contacts, right? Or we can do create table as select. So create table silver.contacts CTAS this time as select star from DBO contacts. So we're just showing you a variety of different ways that you can use for table creation and table population with data as well. Now, obviously, all of these methods, they are full loading, right? So we're not doing any sort of incremental methods at the moment. Here, we're just kind of getting a data set and writing it into a table. Okay, so the next section I wanted to talk about was keys. So I've split this into two different parts, primary key constraints and surrogate key generation. So let's talk about primary key constraints first. So there's a few things to bear in mind with primary key constraints in Microsoft Fabric because it works slightly differently to how you might be used to if you're coming from a kind of SQL Server background. There are some differences here. So the kind of high level bullet points to remember here are that primary key constraints need to be added with the alter table add constraint syntax, and we'll look at that in a second. We can't do it during table creation. Secondly, is that in the Fabric Data Warehouse, your primary key is always going to be non-clustered and not enforced. So why do we set the primary key constraint if it's not enforced? What that means is that essentially it's not going to block you from writing the same primary key into the same table, right? It's not going to enforce that. It's only really for helping with things like query planning and optimization of your queries under the hood. Plus, it's useful if you want to kind of document your code and you want to have these primary key relationships between your tables documented. So let's look at what this looks like. So as I mentioned, you can't do it during table creation. So if I create this new table here, dbo.products, I can't add the primary key identifier against my primary key or the column that I want to be my primary key. But what I can do is this alter table. So I'm going to alter table dbo.products, add the constraint as my primary key on products, primary key non-clustered, choose the specific column that you want to assign your constraint to. Finally, all important is not enforced. So that's the syntax for creating a primary key constraint on a column in a table. We can review that with this information schema query just by looking at, all this is really doing is finding the constraints and the constraint type for this table just to confirm that this has been successfully applied. So we've got our PK products primary key. We've confirmed that we have now applied that. And just to kind of confirm that not enforced part of the primary key constraints, what we can do is we can do a little bit of a test. We can insert some data into dbo.products. I've got two values here. both with the same primary key. So we set the first column here as our primary key. So what I'm doing in effect is creating duplicate data in that primary key column, just to show you that it allows me to do this, right? So the command has been successfully executed. It's not going to reject it. We can confirm that just by having a look here. So this was our primary key constrained column, and we've got duplicate data in there. That's something you have to pick up on your side as the analyst in these kind of OLAP environments. It's common to have your primary key constraints not enforced. Now, there's a few reasons for that. It's primarily an analytics environment rather than a transactional inserts, updates, deletes type environment. So that's less of the focus, right, to have this constraint enforced. Okay, so I'm just going to delete one of those duplicate data rows just so that we can carry on with this example. And I want to talk about surrogate key generation now. Why is this important, and what is a surrogate key? Well, in most source systems, we have what's called like a natural key, right? So you might have product IDs or employee IDs, and they're in your relevant source system, okay, your products database or your HR database, for example. Now, these are useful, and you're going to be using those a lot in your analytics because your end users, that's what they probably recognize, right? But it can be a good idea to also generate what's called a surrogate key. Now, a surrogate key is generated in your analytics environment, which for us is Microsoft Fabric. It's a unique identifier, but it doesn't depend on any of the data. So it's not generated normally from what you have in your source system, right? It's completely independent. And that independence is useful for a wide variety of reasons. It's particularly useful when we want to do SCD type 2 dimensional modeling. And we'll look at that in a moment. The reason being is that when we're doing this type of modeling, we're tracking history over time. So it's likely that you're going to have multiple rows with the same product ID. In doing so, what we can do is generate a surrogate key so that we do have something unique that we can join to other tables, join to our fact table, for example, as well. Now, how do we do this? Well, unfortunately, identity columns are not supported currently within the Fabric data warehouse. So there's a few different workarounds. I'll be showing you a popular one that is in the documentation. So what we're doing here is I've created a new schema called staging. I've created some updated products as like a staging table that we're going to use for our loading. And I've inserted into some data, 10003, I think this is a product, new trampoline product. So let's just run this. Okay, so this is some code that you might see if you want to create surrogate keys and manage surrogate keys using T-SQL in the Fabric data warehouse. It's essentially declaring a variable, and here mine's called maximum product surrogate key. And what we're doing here is saying, well, if anything exists, if we've got any rows in our dbo.products table, then what I want to set my variable here, max product surrogate key, to the maximum value, right? So if you've got 1,000 records currently in dbo.products and it starts at 1, right? Well, here it actually starts from 0 because the else side of it starts from 0. So let's say you've got 1,000 records and it's working correctly. You'd expect your max product surrogate key to be 999 if it starts from 0. So we're going to be able to set our variable, the one that we defined up here, to 999. And then when we go to insert data into our products table here, we're going to use that as the basis of our new surrogate key number. So what this is doing is basically saying, okay, take the current maximum surrogate key, which in our example was 999, and then we're going to do a row number over the product surrogate key, but it's in the updated products table, right? So what this will be is it's going to be row number 1, 2, 3, 4, 5. Everything in this staging table that you're trying to bring into dbo.products is going to give it a row number, and that's going to get added on to the maximum value, right? So the first one is going to be row number 1. And so you're going to get 999 plus 1, 1000, and so on for the amount of rows that are in your staging table here. So let's just run this. And as I'm going through this, it's a good idea to learn about surrogate keys because they're very, very useful. Now, this level of depth perhaps is not required for the DP-700, but just to have an understanding of surrogate keys and some methods and what it looks like actually in the T-SQL code to generate and manage surrogate keys, I think is a good idea. So now let's just select this. Okay, so we had one value in here, which was trampoline small. And now via our staging table, we've managed to create a new product surrogate key. And it's the next one in the series, right? So if we were to look through our code example here, the maximum surrogate key would have been this 1, and then the row number in our staging table would have also been 1, because there's only one value in there. So it'd be 1 plus 1, 2. So that's how that works there. So it's a way that we can assign and generate unique keys based on what we already have in our table currently. Okay, the next section I want to talk about is dimensional modeling, and specifically within the context of the T-SQL, the data warehouse. Now, some of these concepts, they're not unique to the data warehouse, but I think it's a good idea to learn how to implement them because, most of the time when you're doing dimensional modeling, it will be within that gold layer. If you're doing a medallion architecture, normally, lots of companies are implementing their gold layer in a data warehouse, so it kind of makes sense here. Okay, so what do you need to know in terms of dimensional modeling in the data warehouse for the DP-700 exam? Well, I think it's a good idea to have a very strong understanding of different joins, right? Because a lot of dimensional modeling is based on joins between either dimensions and dimensions, or dimensions and fact tables. So that's very, very important. More than just, what a left join is, what a right join is, but about the implications of different join types in terms of the output that you get, how it deals with null values or referential integrity violations, and also their performance, right? So which join types are quicker to execute and how that might be useful in your strategy going forward. That one's more in the optimization section of the exam, but it's all T-SQL, so we'll talk about it a little bit here. So I talked a little bit about referential integrity violations here, which are pretty important when you're talking about joining and dimensional modeling in general. And in case you haven't come across that term before, this is essentially what that means. So when we're joining two data sets together, normally we would have one column that we will join on, right? And it will be shared across both tables. So in this example, it's artist ID. So we have 1, 2, 3 artist IDs in the first table. But in the second table, our artist ID column has 3, 4, and 3. Okay. So in this example, our artist ID of 4 is not in, this is likely to be the dimension table for our artists, and it doesn't have a value for 4, right? So it doesn't really know anything about this artist ID 4. So when you do some sort of joins on them, depending on the join type, it's likely to come through as a null, or it's not going to be coming through at all. So that's referential integrity and why it's important. And the different joining types deal with these kind of issues differently, right? And depending on your strategy or your goal as a modeler or an analyst, you might want to know about these referential integrity violations, right? You want to shine a spotlight on them, or you want to remove them completely. You don't care about them. And that depends on your goals. So let's talk a little bit about joins in the context of dimensional modeling. Okay. So as I mentioned, it's important to know things like left join, inner join, full outer join as a minimum, right? When you should be using these joins, how to perform them in code, what the output is of each of these joins, right? For two data sets, including data sets with referential integrity violations, i.e. where the keys don't match, as we've just talked about. Then how we can filter the outputs of these different joins, right? So normally, or sometimes you can use joins with where statements to give you what you want, and then the performance implications of all of these. So hopefully you're aware of some of the different join types that we have available to us here. We've got the left join up top left. We've got the inner join here, the right join up here. Then we've got some left joins again, but this time we are using a where statement to remove this bit in the middle that we don't want in the output, for example. The full outer join is used here to return absolutely everything. And then normally you can then filter it further to remove anything you don't want in your outputs. So normally some combination of a join and a where statement can get you whatever slice of the data that you want after a join. So if we think about joining now in the context of dimensional modeling, let's just create a few data sets and a few tables here that we can use. Just going to create some tables, dim customers, fact orders here. And we're going to insert some data into these. So let's just run this. Then let's just preview the data. Yep, so the first table, dim customers, has customer ID, first name, last name. Not particularly amazing data sets. Then we've got the fact orders table. as result 2 up here. I've just changed that here. And here we have order IDs, customers, which is actually customer ID, and the amount. Okay, let's start with a bit of a left join on these two tables. All we're doing here is getting the dim customers table and joining it with the fact orders table here and returning a mix of the two different tables here. Now, obviously, this is a very simple join. What I want you to focus on is the output and how it deals with null values on both sides of the join and the total number of rows that you can expect from each of the different join types. So the left join here as an example. So if we inspect what we had to begin with in a bit more detail. So in our result 1, which was our dim customers table, we've got 4 customer IDs. We've got some null value, well, null value here, but it's not in the key columns. And then in our result 2, which was our orders, well, we have orders from customer 1, customer 2, and customer 4. So as you can see here, because we're doing the left join on our dim customers table, we're going to get everything from this. So 1, 2, 3, 4. We're also going to get all of the orders, so the matching fact orders table, which is why we have multiple orders in these rows here. Now, the inner join is very similar, syntactically at least. And if we run this one, this time the output is going to be different. So whereas on the left join, we had the customer ID 3 come through, obviously they haven't actually placed an order, this customer 3, right? So in the inner join, we don't have that customer ID 3 in both sides of the join. So it's just removed from the output. We're only going to get the information for customers that have placed an order. The final one is the full outer join, which is going to give us absolutely everything from both sides of the join. So all of the orders and all of the customers. So it's similar in a way to the left join in this example. But yeah, the full outer join is a very useful tool because it's going to bring through absolutely everything. And then we can then filter down normally, depending on what our needs are, what our analysis needs are. We can either filter on null values in any of these tables and it gives us a slightly different result. So depending on what your goal is, right, the full outer join can be very useful. So that's like the basics of left joins, inner joins, full outer joins. When do we use this in a dimensional modeling process? Well, in that context, it's common that you're going to load your dimensions first and perform that surrogate key generation process that we went through first, and then you're going to load or construct your fact table from these dimensions with your new surrogate keys in them, right? So this is a process and what that might look like. So if to start with, you've got this fact table, but it's got IDs from the source system, product ID, store ID, production ID. First, you're going to perform the generation of the surrogate keys here, and then you're going to join it into your fact table to kind of weave these surrogate keys in and removing the natural keys from the source systems. The end result is that you have these surrogate keys that are unique and can therefore be used, as reliable joins in a star schema, for example, to your dimension tables. The problem is if you just use this initial fact table here, we can't really rely on these natural keys. They might change. There might be duplicate data in there as well, especially if you're performing SCD type 2 modeling of your dimensions. Then the final step is to load fact table into your DBMS. As you can see, this is an old visual, but the process still stands. So we talked about slowly changing dimensions there. And for the DP-700, I think it's important to understand the different types of SCD, or at least type 1 and type 2, probably the most used types of SCDs. Understand the process of what the update sequence would look like for both of those. Now, we do this quite a lot in Fabric Dojo. We've got lots of tutorials going through this in quite high detail. I'll do a simplified version here just so you can understand the update logic for an SCD type 2. So let's start by creating a new table. And this time we've got dim customer SCD type 2. So let's just create this table and then we'll explain some of the key features here. So what we have is, we have our surrogate key. We have our natural key from the source system. We've got a customer name, customer address, and we have a valid from and a valid to field. Because this is SCD type 2 and an SCD type 2, we want to be tracking the history of values in this table. And we do that with this valid from and valid to, these additional columns that are added into this data set. What I'm going to do is just insert some data into that table and then visualize it. And then we can talk through the structure and how that works in a bit more detail. So I've just inserted some values in there. Now let's visualize them. All right. So essentially what this means is that these values here for customer surrogate key 1 and customer surrogate key 2, these rows are valid from this date here, essentially when they were probably modified or when they were created. And the valid 2, in this implementation, I'm using some date very far into the future. Sometimes you see this as 9999, 1231. Sometimes you see it as null values as well in the valid 2. But essentially what this means is that, well, the time now is whatever it is, 2025, February or March even. So we are in these two rows are still valid. Okay. Now, if someone changes something in this row, for example, one of these persons, Jane, gets married, for example, or someone changes their address, then essentially you would change the valid 2 here to, today's date or whenever you have the modified date for that record. And you would add on an additional row into this dimension table with the new data. So let's just simulate what that could look like. So in this piece of T-SQL, we are just simulating what would happen if one of our customers, in this case it's Jane Smith, she's changed her name, so she got married, and all we're doing here is updating our date. So there's kind of 2 steps at a very, very simplified version of an SCD type 2 update step. Well, first we need to update the existing row in our table, which is in this case customer ID 10,003. So first we need to locate that record and update the valid 2, set that value to the load date, right? So this is our current date that I've just generated here. The second step in our SCD type 2 update statement is to insert the new row. So we're inserting into this SCD type 2 with a value of whatever the new value is. So we can run this. Now, this is like a highly simplified version of SCD type 2, just to show you what an update process could look like. But more importantly, how these different valid 2 and valid from columns can be updated. So then if we run this, here I'm getting just the 10003 customer ID from our dim customer SCD2 table, ordering it by valid from. So we can see that now we have surrogate key 2 and 3, but the customer ID is the same, so it's the same person. And we've got Jane Smith has changed her name from this to this. Her address is the same. As we can see, the valid 2 date for this top record has now been submitted, right, as today's date, like when I'm recording this video. And the valid from for our new record has also been added, like so, right, as the same. So normally, these 2 should always match. The valid 2 of the last record and the valid from of the next record. And now this is the current record, right? So sometimes you have an is current column here. So this one would be 1 and 0, because now this row here is the current one, and this one is kind of like archived or historic data. But that's the benefit of the SCD type 2. We're now tracking this over time, so you can build up a really good history of what's happening to all your different dimensions, and you can use that for a lot of different analytics use cases downstream, right? You can do a lot of trend analysis. It just opens up a lot of different analytical capabilities if you're storing the historic data from your dimensions. Okay, so we just wanted to look at granular security again as a bit of revision, right? So we looked at this in one of the previous modules, but very quickly, I just want to recap on the syntax for defining things like row level security, object level security, column level security, dynamic data masking within a data warehouse in Microsoft Fabric. This is a core part of the DP-700 exam again. Now, I'm not going to be running any of these statements because I haven't set up the database, the data warehouse, to actually accept these sorts of commands. So let's just review the syntax, and we'll start off with row level security. So hopefully you remember the 2 or 3 step process for defining row level security in a data warehouse table. First, we're going to create a schema option called security. We're going to define a function, which is going to be a table valued function. Essentially what that means is it's going to return a table, and that table is essentially just a filter of the table that you're applying this function to. So step 2 is to create a function. Here it's called security.filterRows for logged in user. And essentially what this function is going to do is it's going to filter the rows in a given table based on the person that's querying it, right? And we do that with this where sales rep equals to user name. Okay, so that's going to be different every time a different person logs in. Now, obviously, to do this, you have to have your data in a certain shape so that this filter would work, right? You need to have email addresses in that column that match, the person or the people that are going to be logging in and querying this table. Step 3 is this one down here, which is essentially just creating a security policy. And that policy is saying, okay, I want to add a filter predicate, which is going to be the filter that you've just defined on this specific table, right? In this example, it's sales.orders with a state of on, so make it active, essentially. Next up, we're going to talk about object level security and column level security. Now, I'm assuming that you have given the user or the group the correct level of item level security and nothing in the workspace level security. Obviously, that's a prerequisite for object level security. You need to give them only view access to the data warehouse, and then you can grant select on specific tables. Now, if all of that is completely foreign to you, I recommend you go back and I explain this in a lot more detail in the security module of this course. So what we're going to be doing is using grant select on specific table here, sales.orders, to, in this case, it's a T-SQL role here called sales reps. So you can add a user or lots of users or an entry ID security group into that role and use that. Or you can do it to individual people like so, using username at company.com and just their login, their entry ID email address. And we can tweak that slightly to give them access to only a few different columns, right? So this is the CLS example here. This time we're doing a different table, sales.customer details, and we're only giving them access to customer ID and account creation date to sales reps. Finally, let's just review the syntax for dynamic data masking. So this time we are looking at 2 different ways that we can apply dynamic data masking. The first is during the table creation process, like so. You'll see that if we want to do it during the table creation, it's going to look a bit like this. The columns that we want to mask, we use this syntax masked with function. And if you remember, there's 4 different masking functions that we can apply in a Fabric data warehouse. These are the default mask. So the keyword here is default, and we can use that on a wide variety of different data types. We have the email mask, which unsurprisingly is for email type data. It's going to show you the first value in your email address, then it's going to mask everything else, then it's going to mask the email provider like Gmail or Hotmail, and then it's going to show you the ending, right? So .com, .co.uk, that kind of thing. A random mask is for numeric and integers, and it's defined like this. So random with a start and an end of the range. Then we have the partial mask, which is going to show you some characters at the beginning and some characters at the end, and then whatever you want in the middle here. So it's useful for maybe things like social security numbers or bank account numbers, that kind of thing. Obviously, you need to bear in mind the huge warning when it comes to dynamic data masking is that it only applies the mask on what it's showing you in the UI. So the user can still send queries to the database and kind of infer what the data is by progressively sending more and more queries to a table and learning what someone's credit card is. So it should always be used in conjunction with row level and column level security. Okay, I think we'll leave it there for today. Hope you enjoyed that. Join us in the next video. We're going to be doing a very similar thing, but for PySpark. So we're going to be looking at all of the different elements of PySpark that you need to know for the DP-700 exam. I'll see you there.